Hey guys, welcome back to another notes session. Today is April the 1st, 2020. And today we're going to be continuing with circles, moving on to section 9.6, which is called secants. Tangents. And angle measures. That's my angle sign there. Make this E a little bit better. So you already know what tangents are. What is a secant? So a secant, also known as a secant line, kind of like a tangent line, except secant lines cross a circle at 2 points. So just like a tangent line crosses through a circle at 1 point, a secant line crosses at 2 points. So for example, here's your line. A secant line would look something like this. Boop. Just a little line that crosses right through the circle. So here's the point, and here's a point that it touches. Okay, so that's what a secant is. We have three points today, and then we have some examples. So let's do point number 1. And these, I say points because they're kind of like sentences or properties. They're not like vocab words or theorems or anything. Let's just start with number 1. These are kind of lengthy, so stay with me. When chords, what's a chord? It's a line that goes through a circle, but doesn't go through the center. Okay, when chords intersect in a circle, they are divided into 2 segments. Okay, there's another sentence. The product of the segments, product means answer to a multiplication problem. Product of the segments is equal to the product of the other chords segments. I'm going to explain that in just 1 second. Before I draw my circle, I'll read that one more time to you. When chords intersect in a circle, they're divided into 2 segments. The product of the segments is equal to the product of the other chord segment. So, let me show you what I mean. So here we have a circle, right? We have one chord here, D, E, and we have another chord here, A, C. Oh, sorry, this E is supposed to be a B. My bad. Okay, the middle is going to be point E. Well, not the middle, but where they intersect is point E. So what it's saying, I'm going to use different colors here. It's saying that AE, so AE times EC is equal to DE times EB. Just like that. Okay, and we'll do an example because I know you guys like property and then example, property and then example. So we'll do example 1 after this. Example 1. Okay, make your circle. Again, we have 2 chords. We have A, C right here, A and C. And we have DB going this way. So D is up here, B is right here. We have, oh, and then also E in the middle. Duh. All right, so D to E is 12. E to B is 9. Do that one color, and then I'll do AC in another color. C to E is 8. A to E is X, and so we're supposed to find X. So we're going to say 12 times 9 equals 8 times X. 12 times 9 is 108, and that equals 8X. Then you just divide by 8, and X equals 13.5. That was pretty easy. Let's try a little bit of a harder one. This is example 2. We're going to use the same exact rule here. Draw your circle. This time AC kind of goes this way, and BD goes down that way. And don't forget your E in the middle. Just to keep with the swing of things, we'll put AC in green. A to E is X plus 4. E to C is X plus 2. Then we have B and D in blue. BE is X. ED is X plus 10. All right, so we have X times X plus 10 equals the green X plus 4 times X plus 2. This is kind of ironic because in my algebra class right now, I'm teaching distributive property with binomials. So this is perfect. This is exactly what I'm teaching in algebra. Here we use the distributive property to multiply the x to everything inside. So we have x squared plus 10x on the left. On the right, if you know what FOIL is, you can use FOIL or just distribute. Here the x goes there, which is x squared. The x goes to the 2, which is 2x. And then take the 4. 4 goes to the x to be 4x. 4 goes to the 2. 4 times 2 is 8. The left cannot be simplified, so just bring it down. On the right, we have these two middle terms, which can be combined together. So x squared plus 2x plus 4x is 6x, and then a plus 8. Okay, now we can start moving some things around. So let's subtract x squared. Subtract x squared. We do that, and those cancel out. Now we have 10x equals 6x plus 8. Let's take the 6x to the other side, and we get 4x equals 8, and you all know x would equal 2. Okay, so that's our first little rule there, our first point, as I call it. That has to do with chords. Our second one, number 2, is going to have to do with secant lines. Okay, so this is called secant segments. Secant segments. And we're going to write another little small paragraph here. Secant segments go from the point of intersection to the other side of the circle, the other side of the circle, and the outside part of the secant. I'll explain all this after we finish writing. The second sentence says the product of each secant segment is equal to the product of the other. And we draw our diagram. First, I'll reread it all for you. Secant segments go from the point of intersection to the other side of the circle and the outside part of the secant. The product of each secant segment is equal to the product of the other. So here's our diagram. Let's see here. We have a line like this. That's one secant segment. And another line that goes like that. Let me erase this a little tiny bit. Okay, perfect. All right, so this is C, this is B, and this is A. This is D, and this is E. So it's kind of saying the part, I'll do blue here, the part AB from the point outside to the inside, well, one part of the circle, times the whole thing is equal to, again, this part AD times the whole thing AE. Okay, so it's not necessarily like AB to BC, it's AB outside and then the whole thing. Outside and then the whole thing. I'll write this. Outside and then whole. Okay, and same on the right. So let's do one of those examples. What number example is this? 3? Yeah. Example 3. Okay, we have a circle. And we have a line here. And we have a line here. The outside point is called E. We have an H here and an I here. Then F and G. Alrighty. From I to H, I'm going to color code. I to H is X. H to E is 8. From E to F, switch my colors, 10. And then F to G is 24. Okay. So I'm going to start with green. Remember, we do the outside. Outside part is 10 times the whole thing. This whole thing would be 34. So 10 times 34 equals the outside 8 over the whole thing, 8 plus x. 8 plus x. Okay. So again, we have outside over whole times whole, and then outside times the whole thing. So we have 340 equals, distribute the 8. Oops, I don't know why I'm in green still, but oh well. 64 plus 8x. If you subtract your 64, you have 276 equals 8x. Divide by 8, your x equals 34.5. Okay, so that's not too bad. Just remember not to don't put 10 over 24. Put 10 over the whole. That's all you need to remember there. And those are secant segments because they cross at 2 points. Now the last thing we're going to do is look at tangent segments. Okay, so let's go look at a tangent segment. This is point number 3, our last point, and we have one more example, and then we're done. Tangent segments. Tangent segments. when a tangent and a secant segment intersect outside a circle. Okay, so we have one tangent and one secant. The square of the tangents equals secant times outside segment. Okay, so I'm going to tell you what that means. Keep writing. It says when a tangent and a secant segment intersect outside of a circle, the square of the tangent equals secant times outside segment. Okay, this is a pretty specific one here. I'll show you what it means here. Okay, so let's say we have a tangent. Remember, it only touches at one point. So here's A, here's B. That's a tangent line. And then say we have a secant line that cuts through like this. Here's our C, this is D. Then the tangent, look back up here, tangent, which is the AB, squared, the square of it equals the secant, which is AD, the whole thing, and then it says times the outside segment. Well, what's the outside segment? AC times AC. Okay, I'll color code it for you. So this AB squared equals orange, the entire segment, times the green, the outside. Okay? I know these are kind of very specific rules, but we'll go down to our last example 4, and then we're finished. Example 4. Here we have our circle. We have our tangent line. A is here, D is here. We have our secant line. We have B and C. All right, so we're going to say that our tangent AD is 5. Our entire, or let's just say AB, the outside, is 4. And BC is X. Let me do that in a different color. Let me do it in green. X. Okay, so our formula said the tangent squared, 5 squared, is equal to the entire secant, which is 4 plus X, this whole thing, times the outside, so times 4. Let's simplify that a little bit. 5 squared is 25. Distribute. 4 times 4 is 16. 4 times X, 4X. Subtract 16, we have 9 equals 4X. It's going to be a decimal, 2.25. So X is 2.25. Alrighty guys, so that's it for the notes today. I'm going to give you some practice problems tomorrow. So actually I think they're already posted. So you can go look at those, and then we're going to have a small quiz, like 6 or 8 questions on secant lines, tangent lines, and everything we've gone over this week. So be ready for that.